Hi, hope you had a great day. Why don't you get comfortable and let's just start talking about simplifying complex fractions. So here's what I kind of need from you, okay? These, for some people, these look very frightening, but I need you to trust me. They are a whole lot easier to simplify than what it looks like. And so before you just automatically say, oh, I'm so confused, just kind of like breathe deep, exhale, and then let's just think about what I'm saying, watch what I'm doing, listen to me, and then we'll proceed from there. Trust me, I'm not going to let you sink. This is a whole lot easier than it looks, okay? So we're first going to talk about what a complex fraction is. Then we're going to discuss the whole technique of finding the least common multiple. We're just going to find it of more terms than what we're used to, and then we're going to use it to simplify a complex fraction, okay? So let me set my pen here. Okay. All right, so a complex fraction is a fraction that just has another fraction inside the numerator or the denominator or both. So we could have 1 over x plus 1 over y. Oh, come on. Divided by 1 over xy. That's a complex fraction. You just have fractions inside fractions. We could have x plus 3 over 2 divided by 2 over x minus 4. It's just a fraction over a fraction. This one looks really, really complicated, but I assure you that it would simplify probably pretty easily. Okay? So here's the thing that we have to look for. Whenever we are simplifying a complex fraction, just factor whatever needs to be factored, whether it's in a numerator or a denominator. All right? Then take every single one of those denominators, maybe call it a mini denominator, and exclude those factors from the domain, okay? All right, then look at all of those many little denominators and find the least common multiple of all of them. So every single one of those factors has to be included, raised to the highest appearing exponent. Then what we're going to do is we're going to multiply every term by that least common multiple. We're going to cancel, we're going to distribute, we're going to simplify. Okay, so let's give this a whirl. Okay, so let's not freak out. So what I want to look for, here's my complex fraction. 1 over x plus x over y, all divided by 1 over y plus 1. Okay, do I need to factor any of the numerators or the denominators? Not needed. So let's just write NA or not needed. Okay, just so that we know we checked for it. Now, let's state the domain. Well, this domain would exclude 0 for x, and these two denominators would exclude y. So I'm going to have all xy's such that x cannot equal 0 and y cannot equal 0. So that's not too bad, right? Okay, so what is the least common multiple of all these denominators? Remember, we have to have every factor represented raised to the highest appearing exponent. So I need an x, I need a y, x to the first, y to the first. I've already got a y to the first. This is just 1. I don't really need to write 1. I mean, we could, but we don't have to. Now I'm going to take this xy and I'm going to multiply it by every single term. So watch what I do. So this is xy times 1 over x plus xy times x over y plus xy times 1 over y plus xy times 1. Now I'm going to cancel where I can. I'm going to change my pen to red to cancel, okay? So notice that I have an x in the denominator and an x in the numerator, so I'm going to cancel those. What's left? Y times 1, and I get y. The x is gone, okay? Now I'm going to move over to my next term. I have x times y times x over y. Notice that I have a y in the numerator and a y in the denominator. What's left? X times x plus x squared. My denominator is gone. I still have this division sign right here. Now I have x times y times 1 over y. My y's cancel, and what am I left with? X. And then I have x times y times 1. All right. Now we could factor out an x there in the denominator, but we wouldn't be able to cancel it with anything, so it's really not needed. And so this is my simplified complex fraction, not so complex anymore. And my domain would just be whatever I wrote up there in purple, all xy's, such that x cannot equal 0 and y cannot equal 0. That's not so bad, is it? Is that too bad? Okay, let's try another one. Do I have to factor any of my numerators or denominators? Nope, I really don't. Sorry, we're going to have some barking dogs if you can hear them. So this is not needed. Let me switch back to purple here. State my domain. Well, I can have any x as long as x doesn't equal, whoops, that's an xy. I can have any xy as long as x doesn't equal 0 and y doesn't equal 0. Okay? Now, what's the least common denominator, least common multiple of every one of those denominators? Well, I have to include a 2x and a y squared. I already have a y squared here, and I already have an x. So it's going to be 2xy squared. And now I'm going to take that 2xy squared and I'm going to multiply it by every single term in my expression. So I'm going to go 2xy squared. I'm going to multiply that. And I think I'm going to go out here to the side. 2xy squared. Can you guys? No, that's not going to fit. Sorry. Go on the inside. Tried to leave enough room. Times 2xy squared. Oh, my 2 can't fit on there either. Bummer. Okay, I got to squeeze it down just a tad. Bear with me. 2xy squared. Okay. And then 2xy squared and 2xy squared. Remember, now we get to cancel. Okay, and this is why our many denominators disappear, because we get to cancel now. So the 2x is going to cancel, and I get 3y squared. And then I'm going to cancel my y squareds, and then I'm going to get plus 2x squareds. And then I'm going to cancel my y squareds here, and I'm going to get 2x. And I'm going to cancel my x here, and I'm going to get 2y squareds. Okay, and again, we could factor out a 2 here, but it's not going to give us anything to cancel with, so no worries. And then we're going to say, or I'm just going to rewrite my domain here such that x cannot equal 0 and y cannot equal 0. So that's not so bad, right? right? Okay. All right, this one looks a little bit more complicated. Do I need to factor anything? No. Can I state my domain? Well, I can't have x plus y equals 0. So x plus y cannot equal 0. So that means x cannot equal negative y. And I have x minus y can't equal 0. So that means that y looks crumbly. So x cannot equal y either. Okay? Okay. Now, the least common multiple. All right? So look, I have, highlight, I have an x plus y. That's a factor. So make sure you are thinking, oh, these all have parentheses around them. Okay? Because they can't be separated. I don't have 1 over x plus 1 over y. I have 1 over x plus y, 2 over x plus y. Okay? I need to switch my color. Okay. All right, so I need to find the least common multiple. So I need to have an x plus y to what power? To the first. And then I also have to have an x minus y, right? And so I have to take this least common multiple and multiply it by every single one of those terms. So I have an x plus y and an x minus y. Got to squeeze this in. X plus y, x minus y. Sorry, that that does not fit very well. X plus y, x minus y. X plus y, x minus y. Okay? All right, so now I'm going to cancel where I can. I'm going to use red to cancel. Okay? My x plus y in the denominator is going to cancel with my x plus y in the numerator for that first term. So now I'm going to have 2 times x minus y. Now my x minus y is going to cancel with my x minus y. So now I have plus x, that's my original numerator, times x plus y over my x plus y is going to cancel with my x plus y. X minus y times 1. 1 times x minus y plus, here my x plus y's cancel. 1 times x minus y. Now I got to clean this up. All right, cancel, distribute, simplify. So I get 2x minus 2y plus x squared. I hate it when it looks bad. Plus xy over x minus y plus x minus y. All right, so now I have x squared plus 2x minus 2y plus xy over 2x minus 2y. Woo! I barely made it in there, okay? So now try the video question and then come on back. Okay, now we're going to talk about an application of these complex fractions. Harmonic mean is calculated by the formula 2 over the complex fraction of 1 over a plus 1 over b. This formula relates the lengths of two instrument strings, so it could be a guitar string, violin string, cello string, okay? And the lengths are a and b, and it relates them in a way that will produce harmonic sound. So find the harmonic mean of a pair of string lengths when A is equal to 3/4 and B is equal to 3/5. So here's what we have to plug in. We have 2 over 1 over 3 over 4 plus 1 over 3 over 5. Now with numbers, things are even a little bit easier, okay? So what I can do is this 1 over 3 over 4, that's the same as 4/3. So this is actually 2 over 4/3 plus 1 over 3 over 5, that's actually 5/3. Now I have a common denominator, so I have 2 over 9/3. What's 9/3? 3, so this is just 2/3. So a string length of 2/3 of like 1 would be a unit, whatever was the normal or the standard string length. But if you wanted to harmonize a 3/4 unit and a 3/5 unit, then you would need to harmonize with a 2 over 3 or a 2/3 string length. Okay? So this is what we're going to work on in class. Thank you so much for listening to my instruction video. I appreciate all your effort. Thanks.